bell for the end of the school day may have rung, but the learning doesn't end there. This is your geography revision session. We're covering Year 9, Module 2, The Living World. I'm Mr. S, and I'll be your revision tutor. The Living World module is all about investigating how our planet has different types of flora, which are plants, fauna, which are animals, and different climates. We are interested as well in how all of these things interact and adapt. As always, we have 5 elements to look at, so let's start with ecosystems. In this section, we're looking at where do we find our different biomes, which are ecosystems on a really large scale. We're also looking at the different types of processes that occur within an ecosystem as well. Let's have a look at the map at the top of the presentation. You can see it's been coloured to represent different zones. The zones that we're interested in today's revision session are the blue one at the top and the red one running through the centre. So the blue one is our polar environment, or our cold environment, and we're going to split that into 2 when we're looking at it today. One will be polar and one will be tundra, and these are areas of extreme cold and actually quite dry. In contrast, we're going to also be looking at this red section here, which are called tropical, and these are the areas where we find our tropical rainforests, and they are very warm but also very wet as well. And the reason why we get these contrasts is to do with the amount of sunlight that we get and the different climates, the different weather patterns that we find in these areas. The tropical has the equator running right through it and to about 10 degrees north and south of it. And this is important because even though it gets a lot of sunlight, it also means that because there's a lot of evaporation happening and taking all that moisture from the ground up into the atmosphere, it's also creating a lot of storm clouds, rain clouds, which produces rain. So we're getting warm and we're also getting wet weather conditions all year round. In contrast, in the polar environments, that's not getting as much sunlight because it's too far away from direct sunlight from the sun, and therefore it's going to be a lot cooler. And there's not as much moisture in the atmosphere, which means it doesn't rain as much, so it's quite dry. Now, there are a few different types of services and processes that are happening in every single ecosystem, and they'll all be very different depending on which ecosystem, which biome that we're looking at. But as a general rule, we will find the nutrient cycle, the carbon cycle, and food webs occurring in all of the biomes that we're going to look at. The nutrient cycle is looking at how does nutrients operate and circulate around that environment, around that biome. So you can see here we have a very small example. So we've got a tree, and it starts with soil storing nutrients. Now, these roots are going to take the nutrients out of the soil when it absorbs water through the roots, and it's going to store it within the plant. So the plant uses those to grow. When the plant loses its leaves, or when the plant dies, then it's going to deposit them back on the ground, where that plant matter will decompose and break down and become part of the soil again. So this decomposition happens and it becomes part of the soil when that organic matter is decomposed, and the cycle continues. Now, we can also get additional elements of nutrients into this cycle from rain. So rain will bring nutrients with it, and as it rains it will filter down into the soil. And we can also get some really far down in the soil as part of the bedrock, and when that breaks down it adds nutrients to the soil that can be added into the nutrient cycle. So that's a really simple version of that. The second one is the carbon cycle, and the carbon cycle is looking at how does carbon again circulate around an environment. So you can see the carbon is found in a lot of different types of locations. So for example, it's found underneath the ground as part of fossil fuels, or just fossils basically within the rock. We have animals, we're made up of carbon, but we also breathe out carbon dioxide, so that ends up going into the atmosphere. Plants respirate as well, so they breathe out CO2 at night when there's no photosynthesis occurring. And when animals and plants die, they deposit carbon inside their bodies back into the soil. And this is continuing in a cycle. So there are natural cycles of carbon, which is what I've just discussed. But there are also man-made elements to this as well. So you can see here over in the corner that we've got factories. Cars as well all produce carbon, which is put out into the atmosphere. And then finally we have food webs. Now we've got a few variations on this. So we have something called a food chain, which is a simplified version which is only looking at one series of a food web. So you've got your plants as your primary producer, so they take sunlight in and grow. You've then got your first consumer, so that's your herbivore that only eats plants, and then the energy is transferred into the secondary consumer, in this case like a field mouse, and that goes up into your next consumer, which in this case is an owl. So they're showing the flow of energy but only through one series of this. A food web is more complex, and it shows you the entire connection between all the different animals and plants within an environment. So you can see in this one we've got our primary producer, and then we've got our primary consumer is not just the cricket but also the rabbit, and that goes all the way around how this is linked together, and it shows the flow of energy from that primary producer all the way up to the hawk and the owl. But there's a lot more going on in there as well. Next up are tropical rainforests. Now the tropical rainforests, as we discussed in our last slide, occur around the equator. So tropical rainforests are located between 0 and 10 degrees north and south of the equator, where the temperatures are nearly always at least 28 degrees Celsius all year round, and they receive a lot of rainfall, around 2,000 millimeters of rainfall a year, which is massive compared to UK standards. Now, as you can see from the diagram on the left hand side, a rainforest can be divided into 4 distinct layers. So if we start at the ground, we've got the shrub layer, and that can go up to around 10 meters in height, and generally has, as it sounds like, shrubs, dense layers of low foliage. We then go to the under canopy, which has our smallest trees. These are probably young trees trying to grow and find sunlight to rise up, and they can be from around 20 meters to around 30 meters in height. The next we have the canopy. Now the canopy is where we find most of our trees. They found an equilibrium between their height and the availability of sunlight. And then we have a final layer that can get up to around 50 meters in height, which is called the emergent layer. Now this doesn't actually have that many trees in. There'll only be 1 or 2 trees that actually reach this height, and they're the exception to the rule. They've managed to exceed their usual height to get as high as possible, to get as much sunlight as possible. Now rainforests are really dense forests. Down in the shrub layer, it would be very difficult to find a lot of sunlight because this canopy layer is effectively blocked it all off. Vegetation competes for sunlight, so the emergent layer have grown to be taller than the other trees as an adaptation, a change to try and get more sunlight. When a gap opens, when a tree falls, trees grow very, very quickly, responding to the availability of sunlight, and can grow incredibly tall within a matter of weeks to try and exploit that gap in the canopy and receive as much sunlight as possible. The rainforest actually provides a lot of services, not just for the areas that have rainforests, so places like Brazil or Indonesia, but for the entire world. Rainforests regulate our climate and our air quality. They produce their own rainfall as the trees expel intercepted water, which is then evaporated to form rain clouds. They take in carbon from the atmosphere and expel oxygen. It prevents soil erosion. These giant roots anchor the soil in place, meaning it isn't washed and blown away and turning it into desert. It's a good carbon store because again they're taking that carbon dioxide in and they store it within the trunk of their trees. And they're providing us goods. It could be food, fuel such as wood, or there's coal underneath as well, food and water. And finally, let's consider the adaptations. I've already mentioned one. Some trees will grow exceptionally tall to exploit the availability of sunlight. But these wide roots that are represented on this diagram here are called buttress roots, and there's an example in real life on this side here. And buttress roots are really wide bases for the trees. They have to grow incredibly tall, in some cases up to 15 meters in height, which means that they need a strong, wide base to make sure that they don't blow over and become unstable. They do that by keeping a lot of their roots above ground, instead of where we'd have trees in our biome, the temperate deciduous. The tree roots are firmly underground. They don't go down too deep either. Most of the quality of the soil is quite poor. It decomposes really quickly and gets absorbed really quickly on the surface, so their root base is kept on the surface as well to absorb as much nutrients from the soil as possible, even though the soil is quite poor. Secondly, there are lianas, and these are woody vines. They grow really quickly, and in order to get sunlight, they use other trees, and you can see an example of this on my diagram here, this darker twined vine going all the way up the top in the emergent layer. And you can see another example here, these vines wrapping around an existing tree, trying to find sunlight really quickly by exploiting other vegetation to get to the top. And then for an example of fauna, we've got the sloths. Now there's lots of different animals we could have chosen in the rainforest, but sloths have adapted to life in the rainforest by moving really slowly, and that means that they can avoid being detected by predators. So their fur is shaded to match the trunks of the trees, and if they move slowly, they're less likely to be noticed. They have really strong arms and claws to grip branches, and algae will actually grow on their fur as well to again match in with the rainforest. Next up, the impacts and the management of tropical rainforests. Humans have devastated massive amounts of the rainforest over hundreds of years. We've exploited the trees in order for fuel, we've exploited the ground underneath rainforests for their resources, and we've just chopped them down because we need more space. But this is unsustainable, and the rainforest, as we've just discussed, provides a lot of services that are necessary for human life and our way of life as we know it today. Now, some of those things include logging. So we're chopping down trees for fuel wood, so we're burning the wood that's been chopped down, to use it for shelter, or to produce things like paper. We also have to get from A to B. We may have cities on different sides of the rainforest, and they chop down part of the rainforest to put large motorways or rail networks or even power lines through the rainforest to connect places together. Also mining. Underneath the ground of the rainforest, there are huge reserves of things like diamonds, coal and gold. But in order to get there, we've got to chop down those trees to start digging under them. We also have the issue of ranching. And ranching is where we chop down large areas of the rainforest so that we can graze cattle for beef production. And there's been a huge issue because a lot of our fast food chains in the UK have actually used cattle that has been ranched in the tropical rainforests. And there's also for energy, a lot of water is available in the rainforest, so they've cleared out the area so they can build hydroelectric dams. So what have we tried to do to make our use of the rainforest more sustainable? Well, we've got agroforestry, an area of land that is chopped down to grow crops. There are laws in place in some countries where they have to also plant trees back as well. So you grow your crop, and then around the outside of the crop you have to grow trees. And that means that not as much of the rainforest is lost. We've also got selective logging. So instead of chopping down every single tree in an area, people chop down only the trees that are of a certain age or are diseased, so they're likely to die soon, or are already on the way to being blown over, for example. And they won't chop down rare species of trees. There's also a lot been going on in terms of education. Educating the locals about why it's bad to chop down the rainforest, educating them on ways that they can do what they need to do, but in a more sustainable way. And even like the education that you're receiving now, you now understand how the rainforest has been impacted. And this all lends towards a collective response and a collective understanding of why that rainforest is so important. There are huge networks of charities and governments that are now replanting trees on areas that have been deforested, and this is called reforestation or afforestation. And then finally, some governments have decided to create nature reserves or forest reserves, areas of forests which are protected from any sort of deforestation and will also be funded by ecotourism. So that's what this picture is showing here, where groups of people, not huge groups, just small groups, are brought into the rainforest and they pay to do so to go on a holiday, but it's done so in a way that doesn't impact on the rainforest. And the money made from that goes towards the local economy and towards preserving the rainforest as well. We're now going to look at our second and final biome, and that is the cold environments. And we've split this down into two. Now the cold environments is on our original map, that area right at the top of our poles, but it also includes the South Pole as well, the Antarctic. And we can categorize these as polar and tundra. Now polar is the area right to the north near the poles. And this is the coldest area. So the climate of the poles is long winters and the temperatures never or very, very rarely get into the positives. So they're usually in freezing temperatures all year round. The polar areas are really windy and there's no precipitation. So that might sound odd to you because you can see in this picture on the left hand side there is a lot of snow. However, snow is not accessible water. You need to do something with that snow to make it water. So actually the polar areas, Antarctica and the North Pole, are actually dry deserts. They're areas that don't have accessible water, but they're cold. The soil here is covered in ice all year round. And the plants, although we don't really see species of plants that we understand or we know, there are examples that do grow there, particularly algae and lichen and mosses, which you can see on these photographs here growing on the rock. But because the conditions are so harsh, you're not going to see the normal plants growing because there's not enough water and the large amount of wind is going to destroy those plants before they manage to take hold. The tundra is a little further south, so it's slightly warmer, and it has periods of both being frozen and thawed, and during the summer looking a bit like this. So this is what the tundra would look like in the summer. So you can see here there's a lot more vegetation than you can see in the polar area. So the climate here, it is still cold, it is windy, but they do start to get a little bit of rainfall. And with that, during the winter it's covered in snow, so it'll look more like the polar during the winter, but most of the southern parts of the surface do melt during the summer months. The soil has high levels of organic material, so it has a high amount of dead plant and animal material because during the winter it freezes, which means it can't decompose back into the soil. For the plants, you're not going to see big trees. So in here you don't really see anything sticking up in the distance like the trees that we would see. But we do get very small shrubs and small plants, as well as the algae, lichen and moss that we find in the polar areas. So for example, small flowering plants and cushion plants as well, which is a bit like mosses. So how have animals and plants adapted to the cold environments? Well, if we start with the bearberries, these are found in the tundra and they're low growing, so you can see they're growing in between gaps in rock. They've got these really waxy leaves, and that's important because although there is a lot of snow, there's not a lot of rainfall. And with a lot of wind, if they didn't have waxy leaves, all that water they've got stored in the leaves would be wicked away. It would be stolen by the wind and carried away, so the plant would dry out really quickly. So that waxy covering stops the plant from losing moisture. It's low to the ground so that it doesn't get attacked by the wind very much. And if it grows in between the rocks, it becomes slightly sheltered, making it easier to grow. Second up, we have lichen. Now, lichen are found in both the polar and the tundra area. And lichen are unique because they don't actually need soil to grow. And you probably find them more on rocks and even growing on the sides of trees. And it grows very slowly. They can withstand freezing temperatures and survive even underneath the snow when snow arrives on the tundra area. And you can see two examples in this picture. So we've got some orange lichen here and some green and black lichen as well. So there are hundreds of different variations of lichens and moss. And then finally, the polar bear. Now, the polar bear has been massively adapted to life in the polar and tundra regions. It has huge layers of fat which help it to store and retain heat. The fur also helps it to blend in with its environment, making it harder to spot. But its skin, although you can't see much of it, but you can see around its nose, mouth and eyes, is actually black. And that's important because dark surfaces take in more heat, making it easier for that polar bear to retain the heat that it's got. And finally, we have the impacts and the management of cold environments. Humans again have had a devastating impact upon these polar regions. For example, oil extraction, we can see in the picture here, oil tankers that have spilt and caused pollution within the oceans around our poles. So tankers or pipelines can lead to direct fatalities of organisms, so the oil can kill, and the buildup of toxins within the food chain. So if a fish is swimming in this toxin and it's eaten by a polar bear, then that's going to damage the rest of the ecosystem, the rest of that food web, because it's brought toxins into that environment. We overfish, for example, krill, which are really small organisms in the water. We are overfishing the krill, and we also overfish lots of different varieties of fish in our southern oceans near Antarctica and northern oceans as well. And this has a huge impact on our food web again, because it means that there isn't enough for the secondary and the tertiary consumers, so like for example the whales and the penguins, to eat, and so it has a negative impact on the entire food web again. We have issues with, for example, off-road vehicles, particularly in the northern tundras, where because it's a popular activity to go on off-road vehicles, perhaps for hunting purposes and for fishing, then it's destroying the environment because those four-wheel drive vehicles are tearing up the soil and the vegetation of the area. And then finally, we've got issues of tourism. There is huge tourism that goes on within both poles. So people go to visit Antarctica, or they might go to see the fjords, or they could go around the Arctic Circle. And that increases the pollution because those cruise ships are going to run on diesel. But also when tourists get off, they often leave litter around in the area as well. But again, humans have also tried to become more sustainable in their use of the cold environments. Now, oil is a big issue for Alaska and Canada, where they are trying to extract the oil in the ground and move it further south where people live. And you can see here, this is an oil pipe in Alaska. Now, oil pipes can disrupt the caribou, see these reindeer here. If this pipe was really close to the ground, the caribou couldn't move and migrate past this pipe. So you can see that they've actually built them on stilts so the caribou can continue their migration underneath the pipes. They include pumping stations to keep the oil moving, so if it stays for too long and it gets a leak, it means it might pollute the ground around it, so if you've got a pumping station keeping it moving, there's less chance of that occurring. They insulate the pipes as well. Tundra and polar regions get very, very cold, and that can cause fractures within the pipe or expansion as well, which means that it's more likely to burst, and therefore insulating it is going to reduce that risk. Alaska and some of the west coast of North America are tectonically active, which means that they are more prone to earthquakes. And so they have earthquake detection systems, and when they detect an earthquake occurring, it shuts off the oil flow down these pipes to reduce the risk that the shaking breaks free the pipes and spills oil. And then finally, we also have the fact that there are some natural features, and this running through the natural environment doesn't look very pretty. What they've also done is to try to build some of the pipelines underneath key physical features so it doesn't spoil the natural environment. That's it for today. But don't forget to complete the home study questions to test yourself. Goodbye.